CNC machine axis of the spindle. This is the spindle axis. Please remember all this. This is the milling tool, and this will be moving up and down. This will be Z axis, and here we have a table, a working table, and this table, if you are traversing this side, it will be X axis. If you are traversing this side, this will be Y axis. Okay, and this is the axis coordinates of the CNC machine. Definitely one question will be there. And if I talk about the fixed zero, a particular position, you can see this particular position, lower left corner, this particular will be a fixed position. And this will be constant for a particular machine, and it will be provided by the manufacturer of the machine. And if you want to talk about the float zero, please remember clearly all this. Float zero, see, it is possible on the table itself, on the table of the milling machine, and I am going to fix a particular job. I want to fix a particular job to do some kind of turning operations, or I want to remove this particular material from this. I want to remove this particular material from this. I want to remove this particular material from this. Okay, so what we are going to do is, we are going to start with a particular point on this. Maybe this point, any point. So what we are going to do is, okay, and the cutter, we are going to start the cutter from any point on this. Any point you may be starting the cutter on this. So to make it convenient for the programmer to write the program, what we are going to do is, that particular point will be taken as a reference point. That will be a float zero. Any point on this table or workpiece, we can select a float zero. Float zero is just like a reset button. I told you very simple example. On a pan, we are going to add 1 kg. We are going to add some weight, 1 kg weight we are going to measure. And after this, I want to measure another 1 kg of something else. Something else I want to measure. I can go for the tear. Tear in the sense float zero. That means even though this weight is there, that will be giving you zero reading. And I can add up another 1 kg here or half kg, whatever you want. Okay, so that kind of facility is available in the CNC machines in order to go for the programming. This is available. Okay, and that is about the fixed zero and float zero. And absolute positioning and incremental positioning, there are two methods of showing the dimensions, because please remember, the programming of the CNC machine will be totally depend on how you are going to read the drawing, how you are going to control the movement of the tool on the workpiece, that with what accuracy you are going to move, that will be mattering. So that the dimensioning is one important thing, that analyzing the dimensions of the part, at the same time implementing these dimensions into the programming is also one important part. So while implementing these dimensions into the program, what we are going to do, a programmer can make use of any convenient method, absolute positioning or incremental positioning. And absolute positioning is the absolute position will be taken as a reference. With that reference, all the dimensions will be shown. For example, I have one small hole here. I want to show the PCD of this hole from this point, I have to show. So it will not be mixed mode, because incremental positioning is one programming shift or method, and absolute positioning is one shift or method. We cannot mix them together. Correct, no? And while we are measuring the temperature can be measured in terms of degree Celsius or degree Fahrenheit, like that. Mixed mode cannot be obtained. In the similar way here also, the absolute positioning the programmer may select, or incremental positioning the programmer may select. But one advantage of going for the absolute positioning is that anywhere the errors are there. For example, this particular part I did some measurement, and this part is having its independent measurements. So there will not be any effect. Here in this case, you see this, if I do small error in between or in the beginning, the whole errors will be reflected over the entire structure of the dimensions. So always the programmer will be avoiding using the incremental positioning, and they will be always going for the absolute positioning. The next important thing is the NC motion controls. All these are very, very important. I am telling you, please go through all those. NC motion control, basically we have three NC motion controls. One is a point to point, straight line, straight cut, and contour. Okay, the first one, point to point, this will be mostly used for the drilling operations. And here the tool path, it is jumping from one position to another position. Okay, it is just moving from one position to another position, and here what happens, it will be taking the reference of one axis, one thing, and another one, the in between what happens to the path is not important for us. The initial point and the final point are important for us. What is the traversing path, what is the velocity, and what is the feed, speed, and depth of cut of the tool is not required in this case. So this is mostly used or applied for the drilling operations. And the straight cut is one which is used for the end milling operations. Okay, in end milling operations, the tool will be moved along the edges of the sides of the workpiece, and you can see this, your observation, it is the home position of the tool. From the home position, it is traversing by taking reference of only one axis. You can see that it is taking the reference of y axis, and it is taking the reference of the x axis, it is taking the reference of y axis and x axis and y axis. Okay, and mostly this will be used for the end milling operations. And another important the control of motion is that numerical control, and it is the most complicated movement. And you can see that any curved surface or any contour surface, if you want to generate, you can see here this particular surface or the tool path is not taking the reference of x axis or y axis. It is taking both x and y axis once at a time. So in such a situation, we will be using the contour NC motion. Contour NC motion should be used. So let me have a small discussion. Any discussion is there? NC motions, point to point, straight line or straight interpolation, and the third one is the contour NC motion. These are the three important motions, and already we have discussed the advantages of NC motions. Reduce the non-productive time, that we have discussed already. Reduce the fixturing, because the fixturing and all, it will be very lesser cost. Okay, and all these will be automatically, the jigs and fixtures will be prepared, and there will be multi-purpose. Those can hold any kind of tools. So the reduce the fixture cost and reduce the manufacturing lead time. You know that what is the strength of this particular machine, how many cycles of operation it can be performed, and how many jobs it can complete in a day or in a one shift. All these will be known, so that the manufacturing lead time can be reduced by avoiding simply inventory over the raw materials. Okay, and greater manufacturing flexibility. Okay, and in our this one numerical control systems, it is very lesser difficult to adopt the engineering changes. Any alteration in the production schedule, or change over from one job to the other job, or changing over from one job to the other jobs, in the sense changing over one program to the other program, a small schedule change or small change in the programming in the floor level itself, all these can be accommodated, so that it will be greater flexibility in manufacturing and improved quality control. And as the name suggests, the CNC, computer numerical control machines, will be using the computers to control the activities of the machine movements. So definitely there will be lesser or no errors in the systems. Lesser and no errors in the system, and in other words we can say the quality of the product will be very good. Okay, of course the inline on inspection, online on inspection, there are two methods. In the system itself the inspections will be done, and wherever the errors are there, those errors will be rectified in the machine itself. Those are not observable to any of the people who they are programming or who are standing outside. Okay, the machine itself will be doing all these within the built up design parameters. Okay, so improved quality control and reduced inventory. As you know that in the previous point, reduced manufacturing lead time, reduced inventory in the sense we know what is the capacity of the plant with these sorts of configurations of the machines. So definitely inventory over the systems can be reduced, and reduced floor space requirement. See, to do a small machining work, for example, I want to do a drilling, I want to do a tapping, I want to do some slots or some many operations I want to do. So all those operations can be accommodated in a single machine, so that number of machines we are lying down in the floor surface can be reduced. So definitely the floor space which was earlier used for some other purpose can be effectively utilized. Correct, no? Because almost all the machine work can be done in a single CNC machine, so it will be reducing the floor space areas of the production line. Okay, and this is one, and these are the advantages. And let us come to the disadvantages. Each and every system will be having its own advantages, limitations. Limitation in the other way, it is a disadvantage. Okay, and next let me come to the disadvantages. The investment will be very high. Okay, the investment will be very high, and since these are very sophisticated and the investment will be very high, and the machine had to be utilized effectively, otherwise the head over on the CNC machines will be increased. Okay, one thing, higher investment cost. And the next one is high maintenance cost. Maintenance of these machines will be very high, because the weekly maintenance, daily maintenance, hourly maintenance, okay, monthly maintenance, and whenever there is a breakdown, that maintenance, or whenever there are change in the technology that has to be adopted, there also some changes are required. So altogether it will be increasing the maintenance cost of the machine. Simply you have taken a laptop or a computer, you cannot use till the end. Sometimes the programs will be changing and you are going to use the mechanical softwares. So you have to change the configurations like that. So many built up changes we have to do with respect to the technological changes. This can be done in the CNC machines also. So in other way, it also increasing the investment or the maintenance cost of the machines. Okay, and finding and training the NC persons. So here, of course, it is creating unemployment for the laymen who they are working on milling machine tool or turning lathe and so many other aspects. But here it is creating another one, a wide range of jobs will be created in the NC technologies. So it will be very difficult to find a suitable person to run these programs. But I think it is not applicable today, because in almost all the curriculum of engineering technology, the programs have been adopted and we are going to give the training in the institution level. So this may not be a suitable point, I think, for today's existing situation, but also we'll write it. Finding the NC person, he is trained up person, and training NC personnel. So training NC personnel in the sense training in a single once at a time in while it is his entering is not important. With respect to the change in the technology, change in the program levels, the programmer has to go for the undergo the training. Okay, this is what the training for the NC personnel timely. Okay, this is one. And these are all some of the disadvantages. Please make a note. Write a short notes on. Please make a note, all of you. Write a short notes on the followings. Are you writing? Are you writing? Answer back.
Yes, sir.
Please answer.
Yes, sir.
Say, yeah.
Yes, sir. Yes, sir.
Two length. Pardon?
Yes, sir.
One. You take these as assignments. Two length compensation, fixed zero, fluid zero, absolute, and incremental. And the next one, two length compensation over and fixed zero, fluid zero, and NC motions. It is point to point, straight line, interpolation, and the contour, NC motions. The next one, the last important thing is advantages and limitations or disadvantages of NC machines or NC technology. Okay, or you can say NC technology. So please make you among them 100%. I'll be assuring you there will be one question from this in V2 examination. V2 examination, one question will be there from this one. Please remember this. Okay.